Okay, in this video today, we are going to be looking at dividing decimals and make sure we find the right strategy for the right problem. So this video is going to be a bit of a doozy. I'm going to try to make it a little bit visual for how I'm deciding which strategy to use, and then we will move into actually looking at those different strategies. So I encourage you to pause, rewind, and watch the parts over and over if you get stuck or if you get lost in the solutions here. So we're going to start out here with this picture on the left of this graph. And when I look at this picture, I think about these different strategies and the different problem types. So on the vertical sides here, we have our types of strategies. And so on the bottom, these are going to be our more visual strategies, the things that are based in the models, as opposed to at the top, the strategies that are a bit more abstract. So when you're thinking about this, your visuals would be something, strategies like number lines or bar models. And then the more abstract strategies are going to be things like the algorithm, where there's a lot of math that's happening behind the scenes that you don't see quite in the solutions, but you need to have an understanding of conceptually what's going on for those to make sense. So when we look at the problem types now, we know that on the left side over here, these are going to be our more simple strategy or our more simple problem types, where you are, our more simple strategies and problem types, where you're looking at things like whole numbers divided by decimals, or maybe even like tenths divided by tenths. And these are places where you're going to be able to use like strategies that are solidly conceptual. So what you see in the strategy really very closely models the math. Then as we look on the more complex side, we could be looking at things that are like unrelated decimals, numbers that don't play together very well, because, the book always picks problems that are going to work pretty well, but that's not real life. You're going to run into situations where there's going to be like problems that just don't make sense or that are going to be a lot more difficult. And so over here on this end, this is where your strategies and your problems are going to be more complex, and these are going to be more just like procedural strategies. And so you just need to know the steps, and you need to remember that. First I do this, then I do this, then I do this. And the trouble there is if you forget a step, you don't know what comes next, and so it gets a little bit difficult that way. So as we go through some of these strategies, we are going to start out looking at this visual end of the spectrum down here in this area, things with like number lines, and we might do that for some very basic problems, but then those are going to quickly become not very useful for getting your actual answer, but then they can be helpful for deciding what is reasonable. So that's where the benefit of those are. Then as we move along, we will look at some equivalent fractions, because we do know quite a lot about dividing fractions, so we might as well use that to our advantage. Then we'll probably look at some things as we get more complex into the branching division, which works really well with our related decimals. And then finally, we will get to the end here where we are going to get into long division. Like it or not, it can be the most efficient strategy given the correct problem. So the challenge in all of this, because that's a lot of information, you're looking at visual, abstract, like things that are more conceptual or procedural, and like what in the world do you do when you get to a problem? And so really your goal when you are approaching a problem is that you want to find that strategy sweet spot, something that is efficient. It's not going to have you doing a bunch of extra, unnecessary work. It's going to be accurate. You are going to be getting the correct answer regularly, and it's going to have few opportunities for errors or for mistakes. Oops, sorry about that. So when you look at the problem, that's when you're going to use your mathematical reasoning to decide, okay, based on this problem, like, is it, I'm looking over here at this section, is it like a whole number or some tenths? Because then I could probably do something like a number line or some equivalent fractions. Or are they going to be related? Maybe I could pick branching because I know that I am pretty accurate with that, or I can really easily tell if I've made a mistake. Or are these just not very friendly decimals? So here we go. Now I made a little chart here, and these are the different types of problems that we've covered in this chapter. So we've done whole numbers divided by decimals, decimals divided by decimals, specifically focusing on tenths. Then we moved into some related decimals divided by decimals, and then unrelated ones. So on the left side are the strategies. We'll be looking at number lines, equivalent fractions, branching, and then long division. And so what's important to notice in this picture here is that on the top, like these problems, the wholes and the decimals divided by decimals, these are pretty visual, or they're pretty simple. They're like, they stay in the conceptual area. But there's something interesting that happens, like, oops, I wanted my highlighter for that one, right about here. And so at this point, as we get down into this area, what you're going to end up doing is using patterns that you learned here to use these strategies. So you're going to be taking the problems and you're going to be kind of manipulating them a little bit, so that way they're easier to solve procedurally, but the actual numbers are still accurate. So it's a bit of a trick, or a bit of a challenge, but just know that in class we are going to start out with more of those purple strategies and then move towards those blue ones, because ultimately those blue ones they can be used on a wider variety of problems, because you could do long division with a whole divided by a decimal, but why would you want to? Or you could do branching for tenths divided by tenths, but if you could just use your equivalent fractions and then multiply by the reciprocal, why would you want to go down that road? So let's start out, and we're going to do some wholes divided by decimals. I'm not purple. So I'm just going to go whole divided by decimal, and we're going to start out with a number line. And so the problem that we're going to be looking at here is 3 divided by 4/10. And so keep in mind the language of this can be really helpful when you're trying to make connections and be reasonable with your answer. So this is asking how many 4/10 are in, or can you make from 3 wholes? And so I know that if I had 10 groups of 4/10, that would equal 4, because that would be 10 times 4/10, and that would just move the decimal point 1. And so I know my answer is going to be, a reasonable answer will be a little bit less than 10. And so if I'm looking at a number line, if I start out here at 0, and my goal is to get up to 3 wholes, if I make one jump, and keep in mind I'm making groups of 4/10, I would land on 4/10. Another one would get me to 8/10, and then 12/10, and 16/10, and 20/10, and 24/10, and 28/10. So now I notice there's going to be something a little bit wonky, or not quite as friendly, that happens there. But if I count each of these jumps, I would count 2, 3, 4, 5, 6, 7 full jumps of 4/10. And then this last bit right here, this is only 2/10 away. And so that's not a full group, but that's actually a half of a group of 4/10, because it's only 2/10. So I know that I have 7 full groups and half of a group, so my answer is 7.5. And that checks out with my reasonability answer. So you can see here that how number lines, like, they start to get a little bit not great when the numbers don't play nicely. So that was looking at the number line strategy. But if we wanted to use equivalent fractions, let's look at how we can check our thinking here with equivalent fractions. So you could write this like equivalent fractions and then multiply by the reciprocal, because that's what we're going to do. We know 3 divided by 4/10. Well, this 4/10, if you think of it with those words, is real easy to connect to 3 divided by 4/10. And I know that's 3 wholes. So now it looks like a fraction divided by a fraction. So 3 wholes times the reciprocal 10/4. Now I'm going to look and see, can I simplify? No, no. So I'm just going to multiply straight across. 3 times 10 is 30. 1 times 4 is 4. So now what we have is 30/4. It's an improper fraction. Let's turn it to a mixed number. So I know that's 28/4 and then 2/4. So 28 divided by 4 equals 7, and this is equal to a half. So when I put those back together, I get 7.5. So my answer has been confirmed. Now, there's something here. Remember when I talked about up here that there's this orange highlighted line happening? We're at that point. And we're going to start to notice, we're sitting right here, and we're going to make an observation that's going to help us when we can get to branching and long division more efficiently. So I notice that this 30 divided by, or 30/4 can be rewritten as division, because we know that our numerator over our denominator is the same as the numerator divided by the denominator. So I can rewrite that as 30 divided by 4. Now, our original problem was 3 divided by 4/10. And so if I'm in a comparing mood, I notice that this 3 and that 30, it was like this is 10 times greater. It was multiplied by 10. And same thing with my 4/10 and my 4/1. Those are 10 times greater. So this brings up this idea of proportionality, where with division, if we multiply our dividend and our divisor, remember this is our dividend, this is our divisor, if we multiply them by the same number, by either 10, multiply them both by 10, we're going to have a proportional answer that could be easier for us to solve. So I'm going to leave that orange there for a minute while we look at some tenths, and then we'll see, will this idea of proportionality remain true? So our next problem type is going to be tenths divided by tenths. Keep in mind, if you need to pause and rewatch, go for it. I'm going to try to get through this quickly, knowing that you can just stop whenever you need to. So tenths divided by tenths, if our example problem is 9/10 divided by 3/10, I'm going to go like a number line on this one. I suppose we could do that. We're starting at 0. If we make one jump, we would land on 3/10. If we make another jump, that gets us to 6/10. And if we make a third jump, that would get us squarely on 9/10. So this seems like the answer should be 3. But number lines are notorious for being tricky to keep track of your counting and steps. So let's use the fraction strategy. So 9/10 divided by 3/10 as a fraction, 9/10 divided by 3/10. We're going to multiply by the reciprocal. And then I'm going to simplify these because I know those will both be 1. And then I'm going to actually pause here because, well, no, whatever. I'll keep solving this, but we are going to come back to it. I know this can be divided by 3, and this can be divided by 3. And we are just left with all of this, 3/1 times 1/1. So that moment of hesitation, if we were to multiply by the reciprocal, so I'm going to write this over here again, we simplify these, we are now left with 9, hold up, bro, what happened? 9/1 times 1/3, we know that is 9/3, and here we are again. We have a numerator and a denominator. We can rewrite that as 9 divided by 3. So our original problem was 9/10 divided by 3/10. This problem is that we mathematically reasoned our way and can explain that those two are the same. So again, this is 10 times greater. That is 10 times greater. So if you approach a problem that's like 1 and 2/10 divided by 4/10, we know that we can multiply both of these by 10. Our answer will remain proportional, and our decimal point will move over. So now we have 12 divided by 4, and that equals 3. So this is a way that you can take a more complex problem and simplify it. So that idea of proportionality, that you can multiply your divisor and your dividend by 10 repeatedly, once, maybe twice. You could do it more than once, probably. Why not? And that will get you something easier to solve. So we've looked at wholes divided by decimals, decimals divided by decimals. We've done number lines, we've done equivalent fractions. Now we're going to get into a related decimal divided by decimal. And I'm going to skip the number line and move right to probably this idea of proportionality. And then if we need to go back and check ourselves with equivalent fractions, we can do that. So here we go, related decimal divided by decimal. So related. We are going to be solving 1 28/100 divided by 4/10. Now, I recognize that 28 and 4, those are definitely friendly numbers because I know my factors and multiples pretty well. But let's start out and see if we use this proportionality, is that going to be a helpful strategy for us? So I know what makes this difficult for me is dividing by 4/10. So if I multiply both of these by 10, my answer will be proportional, and I can solve 12 8/10 divided by 4. Now, this looks more like a problem that I would have solved last year in 5th grade. So I'm going to use the branching strategy for this. 12 8/10 divided by 4. I know that in this, I have 12 wholes divided by 4 is 3. And then I'm left with 8/10. And I'm going to write that as 8/10. So 8/10 divided by 4 is going to be 2/10. So 3 2/10 is 3 2/10, like that. So our answer should be 3 2/10. Now, I'm still a little bit shaky on this orange proportionality thing, so let's go back to our original problem. I'm going to solve that in, I guess we'll go with, I want blue today, I think. So we have 1 28/100 divided by 4/10. So 1 28/100 is 128 that ends in the hundredths place, divided by 4/10. We have a fraction divided by a fraction. Let's multiply by the reciprocal. 128 over 100 times 10 over 4. I know this can be divided by 10. 100 divided by 10 is this. Now, I'm going to pause, and in the orange, I'm going to rewrite this real quick just to show you that we have 128/10, which is 128/10. And that's going to be, we have 1 over 1/4. So that's going to be this divided by 4. Interesting. Okay, so it seems like it does work so far. So let's go back to my blue here. We have 128 over 40. And check it. If this was 10 times less and that was 10 times less, this would be 12.8 over 4, or 12 8/10 divided by 4, which is what we solved over here. Interesting. So now I can do some more simplifying, and if I eventually worked my way, because this feels really, really bad to simplify, but you know what? We're in it. We're in it to win it. So 128/40. I know this can be divided by 4. This I know can be divided by 4. So we have this is 10. So 100, I'm going to do this like branching mentally. This is a 120 and an 8. So 120 divided by 4 is 30. And 8 divided by 4 is 2. So 128 divided by 4 is going to be 32. And 32/10 is a 32 that ends in the tenths place. So my answer here is 3 2/10. When I used my proportional reasoning, it was 3 2/10, and so both ways have worked. Now, you know, it might be a good time to look at some long division on this one. So I'm going to keep running with this idea of proportionality because this here seems like something that I could solve using long division. So I'm going to set this up with orange, and if I'm doing long division, I have 12 8/10. My divisor, or my dividend, goes on the inside, my divisor goes on the outside. 4 goes into 1 0 times. 4 goes into 12 3 times, and 3 times 4 is 12. Subtract, and I'm left with 0. Now I'm going to use those 8/10, keep my decimal points lined up, and 4 goes into 8 2 times. So here we have 3 2/10. So we've solved it 3 different strategies, 3 different ways, and we got the same answer. Now let's move into some unrelated decimals. I'm going to get a whole new sheet for this, unrelated. So we are going to be solving 56 hundredths divided by 3 hundredths. So this, oh my, that's a lot of decimals. That's a lot of places there. Let's tell you what, let's be proportional about this. Instead of multiplying by 10, I'm going to multiply by 100 for both of these. That's going to move my decimal point 2 places for each of them. So now I'm solving 56 divided by 3. And if I do 56 divided by 3, branching style, I know that there's a 30 in there. That's 10. That would leave me with 26. And I know that 24 divided by 3 is 8. And that would leave me with 2. So now I have 2 divided by 3. My answer is 2/3. Because I know division can be turned into fractions. So my answer is 18 2/3, or 18 0.667, whatever that repeats forever and ever. So let's look at long division with this one. 56 divided by 3. The dog is being annoying. I don't know what his deal is. 3 goes into 5 one time, and 1 times 3 is 3. Subtract, that's 2. Now we have 2 10s. Let's use those 6 10s from above. 3 goes into 26. 8 times, because 9 would be 27. So that's that. And we're left with, that's wrong subtraction, 2. So those are 2 1s. And I know 2 1s are equivalent to 20 tenths. And so I know that 3 will go into 20 6 times. And that is 18. And those are tenths. So now I'm left with 2 tenths. And 2 tenths is equivalent to 20 hundredths. And that'll go into it 6 times. That'll be 18 hundredths. So I'm left now with 2 hundredths, which is equivalent to 20 thousandths. Oh, man. Oh, my gosh. So that could keep going on forever and ever and ever. But here we have that answer twice. So just to recap, that was a lot. But using what we can observe from these, I don't want red, I would like blue. So using what we can observe and learn from these 2 problems types, we can pick up that pattern of proportionality that allows us to manipulate our original problem, so that way we can use one of the more abstract strategies with our more complicated problems. So the goal is to make observations, come up with patterns that this area that can help us solve these more challenging problems easier. And keep in mind, when you're going from fractions to decimals, any time that your denominator is like a place value type of denominator, so that could be like tenths or hundredths or thousandths, like you don't simplify those, keep those, because that makes it easy to convert. Whatever your numerator is into a decimal is so simple when you have those types of fractions.